Welcome everybody, this is Mr. Gannon. In this video, we're going to take a look at the notes for section 5.1, where the overall goal is going to be solve functions by factoring. Now, we'll be looking mainly at quadratic functions in this unit, but we will also look at other polynomial functions. So to get started, we have a couple tables in here where you would fill them out in your groups or with a partner in class. But I'm just going to go through and show you how we can do this. And you can do it either through plugging in the x values into the function, or if you do have a graphing calculator, it will do a lot of the work for you. So I'm going to kind of show you guys how that would work on the graphing calculator, just to give you an idea of what is happening. So that first function, if we type the function in as if we were going to graph it, all right, we've got x squared minus x minus 6. So we're going to go ahead and go x squared minus x minus 6. And if we wanted to graph the function, we could just hit the graph button. But if you look above where it says graph, there's a table feature. So if we hit second graph, it'll actually give us a table of values. Now, this particular table starts with x being 0, but you can arrow up to get other values. And if you look at the table we have in our notes, we're looking from -3 to +3. All right, so I'm going to go ahead and pull those values. So it was 6, 0, -4. So let me just try to transfer those over. So we have 6, 0, -4. And then we had -6, -6, -4, 0. So -6, -6, -4, 0. All right, so that's what it would look like. Now, it says work with your partner or group to determine which are solutions to f of x equaling 0 and g of x equaling 0. So what we want to look at here is, when does the function equal 0? So that's going to happen here when x is -2. It's also going to happen here when x is +3, excuse me. So f of x equaling 0 means the value of the function needs to be 0, which from the table, we can easily identify those values. Now, I'm going to go ahead and type in g of x as well. So we'll go back and we're going to go y equals, we're going to arrow down to y of 2. And then in parentheses, all right, we have x, let me see the factors again, so -3 and +2. So x -3, parentheses, and then x +2. All right, we want the table again, so we're going to go second table. Now, you'll notice that if you look at the y values, they're the same for each. All right, so if we came back over here, we can really just fill in the same numbers: 6, 0, -4, -6, -6, -4, 0. And again, this function equals 0 at -2, and it also equals 0 at +3. All right, now that tells us something. When all of the outputs of a function are the same, that means that these two are equal to each other. So f of x is going to be equal to g of x, meaning they're the same function, they're just written in a different form. Now, you may remember from chapter 4, this is referred to as standard form, and this would be referred to as intercept form. Now, I personally also like to refer to intercept form as factored form, because that's really what it is. It's standard form that has been factored out. So if you think back to how would you factor this equation, these are the factors that you should come up with, which again tells us what those solutions are. All right, so we have something down here. It says that the solutions to f of x equals 0 and g of x equals 0 are also called zeros or roots of the function. So again, we have that relationship that there's certain words that mean the same thing: solutions, zeros, roots. But then also x intercepts falls in there too, because that's what those look like on a graph. All right. Now there's a couple questions here. One says, how do you find the y-intercept? Well, we can find the y-intercept, if you remember from, again, chapter 4, the y-intercept always has an x value of 0. So you can plug in 0 for x. All right. Then it says, how do you find the x-intercept? Well, one way to find the x-intercept is you plug in 0 for y. Now, once you plug in 0, regardless, you're going to solve the equation that's left. All right, so in example 1, it says, find the solutions for the equation. Now, based on what you guys currently know, think about how you might do that. All right, I'm going to go ahead, plug it in the graphing calculator. While I'm doing that, again, pause the video, try to come up with the solutions on your own. So I'm going to go ahead and pull up the graphic calculator. We're going to clear out what we already had into those two equations. And then just to make sure I plug in the right thing, we have x squared plus 3x. So x squared plus 3, oops, not 3 squared, sorry. 3, oops. All right, and then if we wanted to do our table again, all right, let's see. Does this table start at -3 as well? Yes. So we're going -3 to 3 again. So now we got 0, -2, -2, 0. All right, so let's just start plugging those in. 0, -2, -2, 0. And then 4, 10, 18. All right. Now, again, the question is to find the solutions to the equation, which means when does it equal 0? So this time it's 0 at -3, and then it's also 0 at 0. All right, so our solutions would be x equals -3 and x equals 0. Now let's think about other ways that we could find that. So, we're not always going to want to, well, one, we're not always going to have a graphing calculator available. Two, we're not always going to want to plug in and fill out a table. So there has to be easier ways. And typically, the easier way to do it is to, if we want solutions, set the equation equal to 0, and then we want to factor what's left. All right? Well, in this case, if we factor the right-hand side, we can factor out a greatest common factor of x, and then the additional factor would be x plus 3. Because if we take out x, x times x gives us the x squared, and then x times 3 gives us the 3x that we need. Well, once you have factors, if you are looking for the solutions, in order to multiply and get 0, one of the two factors has to equal 0. So the only thing that's going to make x 0 is 0. And then for x plus 3, we would really be setting up the equation x plus 3 equals 0, and then subtracting 3 from both sides to get -3. Now, it can start to get a little cumbersome having to do this side work all the time. So if you're able to just look at the factor and think, how would I get x alone? We're going to subtract 3, and that's all we need to do to get x alone. That is another way to come up with those solutions, really much quicker than making that table. All right. Now it says, what are other ways to describe solutions? Those are those 4 connected words we talked about. So solutions are also called zeros, which are also called roots, and then x-intercepts. Those are 4 words that always mean the same thing. So you're not doing 4 different things. It's one thing with 4 different words. All right, let's keep going and find some other examples. All right, example 2. Again, guys, try these on your own first, then go back and watch the video. So if we want to find the solutions, the first thing we're going to do is set it equal to 0, and then we want to factor. So first thing you should always think of when factoring is there a greatest common factor? When I have 3x squared and 9x, I know that their greatest common factor is 3x. Now there has to be an additional factor that's going to go in parentheses. And in my head, I'm thinking, okay, what am I multiplying 3x by to get 3x squared? X. What do I need to multiply 3x by to get negative 9x? Negative 3. Those are the factors. Now, in order to find the solutions, we need to know what's going to make each factor 0. So if 3 times x equals 0, x has to be 0. If x minus 3 is going to equal 0, I'm going to add 3, giving us positive 3. So our solutions are x equals 0 and positive 3. All right, so the factors help us find the zeros, but they are not the same thing. All right, number 2, we've got y equals 10x squared minus 2x. So again, we're going to start by setting it equal to 0. When we factor, we're going to look for a GCF, which in this case happens to be 2x. So in parentheses, what times 2x is 10x squared? That's 5x. What times 2x is negative 2x? That's negative 1. From there, we have to find our solutions. Well, the only thing that's going to make 2x equal 0 is 0. And then here, this one can be a little tricky when you're first learning it. The way I think about it is if 5x minus 1 is equal to 0, and I want to get x alone, the first thing I'm going to do is add 1. So that's positive 1. Then I need to divide by 5. So 1 divided by 5 is 1/5, and that is my answer. All right. Now, if that is a little bit confusing to you, what I'm doing, okay, and I'm just, in my head, I'm essentially setting up these two equations. 2x equals 0. And to solve it, I'm going to divide both sides by 2. All right. X equals 0. Because 0 divided by any number is 0. I'm also setting up the equation 5x minus 1 equals 0. And as I solve this, I'm going to add 1 to both sides, and then I'm going to divide by 5. So those two equations are being solved in my head to come up with those answers, which if you need to write out the equations, I would encourage you to do so. All right, looking at number 4. All right, we're going to start by setting it equal to 0. So 0 equals 12x plus 4. Now, again, this cannot really be factored other than to factor out a 4. So I am going to do this by factoring, even though there are other ways to solve this. So let's just erase that. All right, 12x and 4 have a 4 in common. All right, 4 times 3x is going to give me 12x, and then 4 times 1 is going to give us 4. Well, nothing is going to make the 4 0, so there is no answer there. Over here, we would subtract 1, giving us negative 1, divide it by 3 to get negative 1/3 as our only answer. So one thing to pay attention to is in order for there to be a solution from the factor, it's got to contain the variable. 4 is always going to be 4, all right? Whereas 2 times x is going to change depending on the value of x. And that's the way you need to think about it. All right, moving on. It says, what would the graph of these functions look like? And one of the things we're trying to do is build the idea that there's a relationship between the solutions and certain characteristics of a graph. For example, these graphs, as we learned in chapter 4, are quadratic, meaning they're going to be a parabola. The solutions would be where the graph is crossing the x-axis. So in this particular example, this parabola is going to cross the x-axis at 0. It's also going to cross the x-axis at positive 3. Now, this is going to be a very rough sketch of the graph, but it's a positive parabola, meaning the parabola is going to look something like this. Whereas if I look at this graph, all right, my x-intercepts were at 0 and 1/5. Well, 1, 2, 3, 4, 5. I'm going to call that 1. That means that my solutions, or x-intercepts, are going to be right here at 0 and 1/5. Again, the parabola is positive. It's going to open up. So again, all we're trying to do is help build the connection that there is a relationship between the solutions and the graph. The solutions tell us where the x-intercepts belong on the graph. All right, and then if I'm looking at example 4 here, one thing you got to be careful with is this is not a parabola. It's 12x plus 4, meaning it's actually a line. So again, one thing you might remember, maybe not, is that when you graph a line, we would start at the y-intercept, which is up 4, and then the slope would be 12 in this particular case, which means I would go up 12 over 1 or down 12 over 1 here, and then my line would go through here. Well, if I had accurately done this on a graph, this particular value right here would be negative 1/3. So where our graph is crossing the x-axis would be at negative 1/3, which not a great picture right there, but just trying to give you the idea of what's happening. All right. Now, when you take one of these equations and you factor them, you are putting them in what's called intercept form, where A essentially can be considered a GCF, which it won't always be there. And then your other factors containing variables, x minus a root, x minus a root. Remember, roots are other words for solutions, zeros, x-intercepts. All right, so again, moving on, got some more examples. Find the solutions, roots, zeros of the following functions. All right, number 5. We're going to start by setting it equal to 0. All right, we want to see, is there anything we can do to factor out? Well, 3x squared and negative 2x are going to have a GCF of simply x. And then the additional factor, what times x is going to give us 3x squared? That's going to be 3x. What times x is going to give us negative 2x? That's negative 2. And then once you have your factors, now you can find your solutions. What's going to make x 0? 0. Here, in order to get x alone, I'm going to add 2, but then I'm going to divide by 3. So x is equal to 0 and 2/3. One of the most common misconceptions people are going to make is they're going to look and just be like, oh, it's positive 2. All I got to do is add 2. Well, that's not the case. You have to get the x alone. So that's one thing you got to be aware of when you're doing these problems. All right, looking at number 6, similar idea. We're going to start by plugging in 0. All right, this time, when you go to look for your greatest common factor, it should be 3x. And then in parentheses, all right, what times 3x will give us 12x squared? That's 4x. What times 3x is going to give us 9x? That's positive 3. And from here, once we have our factors, we can find the zeros. In order to make 3x 0, x has to be 0. Over here, we're going to subtract 3 and then divide by 4. So x is 0 and negative 3/4. Okay. And just a reminder, if I'm going too fast or you're not understanding how I'm getting 0, I'm setting up the equation 3x equals 0. But I'm doing it in my head and I'm solving. Divide by 3, 0 divided by any number is 0. I'm also setting up the equation 4x plus 3 equals 0. So I'm going to subtract 3, and then the next step, I'm going to divide by 4. So this is the work that's basically being done in my head to come up with the answers in green. All right. Now, example 7, you got to be careful here. It says, what are the solutions to the following functions? Well, 5 and 6 are in standard form. Number 7 is not. All right, number 7 is in HK form. So one of the things you have to learn how to do is look at an equation and decide what is the appropriate method to solve. And in this particular type of problem, if we have a quadratic equation in HK form, we're going to solve by square rooting. All right, and we've done this several times this year. All right, we did it in chapter 3, we did it in chapter 4, and now it's coming back here. So in this case, we want to start by isolating, well, we're really starting by plugging in 0 here, but then we want to isolate the binomial squared. So in order to do that, we're going to go ahead and subtract 8. So then we got 2x plus 3 quantity squared. Divide both sides by 2. That's going to be negative 4 equals x plus 3 quantity squared. Once we've isolated the binomial squared, we can go ahead and square root both sides. All right, now on the left side, we have the square root of negative 4, which hopefully you remember is 2i, but don't forget plus or minus. And then x plus 3 would be on this side. As we go to isolate the x, we're going to subtract 3, which gives us negative 3 plus or minus 2i. Those are not like terms, which means that's as far as we can go with our answer. All right. And when our answers are complex, so I'm going to make a little note. When your answers are complex, the graph has no x-intercepts. And that's because your solutions are imaginary. All right, and that's the key there. So something to just pay attention to as you go through. All right, a few more examples, and then we'll kind of, hopefully get through everything and you'll have enough to get started on the homework. So example 8, same idea. What are the solutions to the function f of x equals 0? Only this time we're given the graph. So what you need to remember is that solutions are simply x-intercepts. So there's really not a lot of work that needs to be done on this problem. It's just knowing that solutions also means x-intercepts. So if we look at our graph, there's an x-intercept here and another one here. So x has to equal negative 1 and then 1, 2, 3, 4, positive 4. Those are the two solutions. All right, now the next question is kind of interesting. It says, what is a possible equation for f of x in factored form? Now, the key says possible, all right, because we might not be taking into account any type of stretch or compression here. But earlier, we were solving equations by factoring. So if we knew the factors, we could come up with our solutions. This really just wants us to work backwards. So we need to basically think is, okay, if our solutions are negative 1 and 4, what is a possible factor that would give us negative 1 as a solution? Well, it's x plus 1. And then what is a factor that is going to give us positive 4 as a solution? Well, that's going to be x minus 4. All right. There's always going to be that relationship between factors and solutions. Okay. So if my solution is minus 1, my factor would have to be x plus 1. All right. Hopefully that makes sense. If not, just come and see me for help and I'll do my best to explain it. All right. Now, we got a couple other problems here. Number 9 says, find the solutions for the following functions and sketch graphs by using the x-intercepts and kind of estimating a vertex. All right, so what I'm thinking here is, all right, we want to find the solutions. So we're going to set it equal to 0. That's the first thing that comes to mind. Then we're going to try to factor. Only this time there is no greatest common factor. So the next thing to do when there's trinomials is to set up two binomials. X squared means x and x. All right, we talked about when this sign here is positive, we have the same sign. They're both going to be minus. And then now we need factors of positive 4. That when multiplied by x and x give us negative 4. Well, that's going to be 2 and 2. So in this case, that means that our only solutions are going to happen at 2 and 2. So x equals 2 is our solution. And that tells me that there's only one x-intercept. So if I'm going to sketch my graph, the x-intercept is just going to simply be right here at 2. The parabola is positive, so it's going to open up. Right. Now, there will be times when we're going to be more specific to what our graph looks like, but just based on what it's saying, sketch the graph, this is all I need to know. Hopefully that makes sense. All right, number 10. All right, same idea. We're going to start by setting it equal to 0. There is no GCF, so we're going to factor it into two binomials. The x squared tells us that it's x and x. All right, a negative in front of the 15 tells us signs are different, so plus and minus. All right, now we're looking for factors of 15. So the possibilities are 1 and 15, 3 and 5. Well, we want the ones that when multiplied by x and x give us 2. Well, we could do some trial and error, but in this case it's going to be 3 and 5. So positive 5 with negative 3. The x-intercepts are going to be at negative 5 and positive 3. And if I was going to try and sketch a graph of this, basically I've got one x-intercept at negative 5. I've got another one at positive 3. All right, we've got a parabola opening up. All right, the vertex is going to be somewhere. It's going to actually not be somewhere. It's going to be directly in the middle of these. So there's going to be some symmetry about the graph, and it would look something like this. With our vertex, you know, in this case, having an x value of negative 1. But we'll talk more about that later. But really, if we're just looking at solutions, there we go. All right, last two examples. So the biggest thing that's different about 11 is now you have an equation that says x squared minus 4x equals 12. Well, just like before, I can only solve this if it's equal to 0. So I'm going to move the 4 over to the left side by subtracting. So x squared minus 4x minus 12 equals 0. Now we can go ahead and factor the left side of the equation. There's no GCF, so it's x and x. The negative here tells us plus minus. Factors of 12, 1 and 12, 2 and 6, 3 and 4. Well, we want the factors that when we multiply them by x and x are going to combine to the negative 4. Well, I know that that's going to be 6 and 2. The 4 needs to be negative, so the 2 is positive, the 6 is negative. But again, you need to be careful because this means that my solution is negative 2, positive 6. And that's where the x-intercepts would be on the graph. So if you were to, again, sketch the graph, you would just sketch out a coordinate plane. All right, we've got one x-intercept left 2, the other one right 6, and then our vertex is going to be right in the middle of those values. All right, now, this problem we have a couple choices. This could actually look a couple different ways depending on how we wanted to approach it. In order for us to solve the equation, we need the equation to equal 0. Now, given the choice, I always want my x squared to be positive. So I'm going to make the 0 be on the right or the left side, excuse me. And I'm going to do that by moving the x squared over here. So I'm going to add x squared to get x squared plus x minus 42. Now I'm going to go ahead and factor it. There's no GCF, so I'm going to do two binomials, x and x, negative 42 plus and minus. All right, factors of 42 are 1 and 42, 2 and 21, 3 and 14, 6 and 7, and then it would go back to 7 and 6, so we know we're done. Well, to multiply by x and x and get positive 1, I'm going to need my 6 and 7. Positive 7, negative 6. And that, again, means our solutions are at negative 7, positive 6. So again, from a graphical standpoint, so 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6. You've got one x-intercept here, one here. And if we had moved things over to the left-hand side, our parabola might open down. But if I'm using the parabola, where we move the x squared over, parabola is going to open up and go through those 2 points. So, hope you guys found the video useful. If you still have questions, make sure you guys see your teacher for help.